Hi, I'm Dr. Christopher Sutton. Welcome to my Introduction to GIS video series. In an earlier set of videos, I introduced coordinate reference systems and their building blocks, including reference ellipsoids, the geoid, and datums. In this set of videos, we will dive deeper into the various ways that we define position in GIS. In GIS, location is determined using coordinates. But why coordinates specifically? First, we need to recognize that there are actually many ways to express our location relative to Earth's surface. We could define where we are by the room we are sitting in, or the campus we are on. We might describe our position by city, state, or even zip code. We can use latitude and longitude. The list goes on. With all of these options available, having a standardized structure for determining position becomes critical. This standardization allows us to place features relative to each other in GIS, which enables us to make maps and perform analysis. So what exactly are coordinates? Simply put, coordinates are values that define the spatial location and extent of geographic objects. A commonly used structure for defining coordinates is based on Cartesian coordinate geometry. In Cartesian coordinate geometry, position is defined using a coordinate pair, x and y, for two-dimensional space, or a coordinate triplet, x, y, and z, for three-dimensional space. Let's look at an example of this Cartesian coordinate system. You can see the x and y axes labeled with numbers representing the distances from the origin, the 0 position for each axis. Using this system, we can define the position of this circle as having an x-coordinate of 3 and a y-coordinate of 4. Defining coordinate position depends on how you're portraying Earth in GIS. Are you treating Earth as a three-dimensional surface, or are you representing it as a flat plane? Cartesian coordinate geometry works well for defining position on a plane, but as you know, Earth is a round three-dimensional object. It's not flat. For a round Earth, coordinates are best defined using a sphere. However, as you saw in an earlier video, Earth isn't perfectly spherical. It's an oblate spheroid with a diameter at the equator that's longer than the diameter between the poles. There is another important consideration when working with coordinates: measurement precision. Defining location is rarely perfect. Error in positioning exists, and the older the data, the more likely it contains positional errors, particularly for data going back decades or centuries. Fortunately, our ability to accurately define coordinate positions has improved dramatically in recent decades. When we define coordinates for Earth using a geographic coordinate system, we use what is known as the graticule, the network of lines forming a grid over Earth's surface. In the next video, we will examine the specific properties of the graticule in detail.